Hello, my Algebra 2 students. I'm making a quick little warm-up video for you just to refresh your memories on solving systems of equations. You did quite a bit of this in Algebra 1, and it's really important for what we're doing today. So the equations that I'm giving you, you can just put this anywhere, a separate piece of paper, are 2x plus y equals 9, and then 3x minus y equals 1. Right? So to solve systems of equations, there was two main ways to do it algebraically. The two methods, I'm going to write them off over here, were called the elimination method. The other one is called the substitution method. Right? Neither one is more correct than the other. And as I go through, hopefully you'll be like, I remember this. Elimination method is where you would line up the equations, and when you added them together, you would eliminate one variable. So the goal was to get one of the variables to kind of fall out. Whereas substitution, you would maybe solve them both for the same variable, and then you would set the equations equal, or you might literally substitute in one for the other. So what we are going to be focusing on more will be elimination, because it'll actually present itself as being a little bit easier in most cases. So to remind you what I'm talking about, I would need the variables in order. So x, y equals, and then a constant. X, y equals, and a constant. And if I actually look at the way they are right now, they are perfectly set up so that if I add the two equations together, the fact that I have plus y here and I have minus y there, when I add them together, the y's will cancel and eliminate themselves, hence the elimination method. So 2x plus 3x would give us 5x. Positive y, negative y would cancel, and then 9 plus 1, we'd get 10. And if you can get it down to a single variable, then it makes it really easy to solve and say, hey, there's x equals 2. To get the other variable, you have to plug back into one of the equations. It does not matter which, because when you're solving a system, you're figuring out where the two equations cross or where they're equal to one another. So if I plug into like the first equation and then plus y equals 9, I can show that here's 4 plus y equals 9, subtract that 4 over. This is going to give me 5. And so I can write the answer like this. I can write the answer as a coordinate point. Either way would be perfectly fine. But what it means is if I were to graph this line and graph this line, that's the point where they would actually intersect one another. Now, if you're someone that has seen substitution method in the past, just to show you what that would look like, you would take the first equation, the 2x plus y equals 9, and maybe you'd solve it for y. So you would rearrange it so you could get y equals, and then it would be 2x plus 9 by shifting that over. What you would then need to do is either solve the second equation for y, or you can actually substitute in place of the y here, what the y is equal to in the other equation. So this would come in and sub over here. So then you would have 3x minus, and in place of that y, we could put in this guy. So we'd be able to put in the negative 2x plus 9, and then you would keep the equals 1. So that's why it's called the substitution method. And if I do it this way, then what I would get here is 3x. This would turn into plus 2x, and then that would turn into minus 9, because you'd be essentially distributing that minus through it. And then this would give me 5x minus 9 equals 1. I could add 9 over to get 10. And then you can see pretty quickly, same answer. And then to finish it, I would plug back in to get the y value. So there's a quick overview of what the elimination method looks like and what the substitution method looks like. All right, now go hop onto the other video and see what we're doing for today.